Let's start with the today's design with this amazing visualizer by DSA.ChaiCode.com. Use this link to get a 7-day free trial. Okay, so today we will be starting this one, depth first search. So yeah, simply depth first search. So what is a DFS or depth first search? In computer science, if you search on Google, like in depth first search is an algorithm which is used to traverse and search tree and graph data structure. It started chosen a root node and then goes down the path as far it can before it turn backs. Okay, even if you so what does this means? This is simply one thing which we actually going through. Like suppose you were given a tree, 1 2 3 6 4 5 6. Okay, how could you traverse the tree? Okay, so you could traverse the tree like this, level by level, or you could traverse the tree like this, go to the depth, then this depth, then come and go like this. So if you traverse it like depth, go to the depth, then come back, then again come back, go to the depth, go to the depth. So what does we do actually here? See, first we go to the all left part, like all of the left part till 4. Then we return back to its right part. Okay, then we return back to this right part. This is how we take. First we go to the extreme depth, then we come back again and again. This is actually a DFS. DFS is an algorithm. We can explore graph and tree data structure with this. It started at choosing a root node and moved down a single path as far as it possible before turning or backtracking to the path. Okay. See, similarly here, it goes till 4, then backtrack to 5, then again backtrack to this 3 and this 6. Okay. So this could be, you can easily find it. Okay, so if you see this here, see the simple pseudocode. I think the visualization is much more better here. So if you see it, that if the root is null, we just return. Okay, but the root is not null, so we visit every node. See, we go till the last index of 4, 1 2 4, then we come back with this 5, then we come back with this 3, and whenever we come back we removing the element, then we go to the 6. This is how DFS works. Okay, this could be the simple pseudocode. Now this is the most of a now I think this is the recursive one. Yes, I want this is the recursive one. See, if you closely observe what we did, we just go like this. So what we actually do, we first go to the left. Okay, if left present, we go to the left. Okay, if there is no left present, it is null, so we return back. Then we go to the right. Okay, go to the left, nothing, go to the right, nothing, we just return back. We just again return back, then go to the right, then go to the left, then again reach null. So see, first we go to the right part, then we go to the left part. Okay, so this is how actually our things works. So this is much more a repetitive step. Like every node we need to find the next left or next right based on the condition, obviously, in a tree. So we can easily use recursion here. So see here, first we just push our first one. See, first we push the root node of the tree, then we put the uh, left node, then again we go to the left and put the left node. Okay, so we similarly we can go and put all our right node like this, and every time we come back we are just removing. We are just removing it. We are just removing the node. See, at the end the stack will be empty here. Simple. Okay. This is how we return things. We can return the number of nodes with this, because every node, every time we just go and check how many node does the, like this one, 1 2 4 5 3, it is 3 and this is 6. So we just go to this node and ask how many nodes are there. We go to this node, checks how many nodes are there. We go to this node, checks how many nodes are there. We go to this node and checks how many nodes are there. And at the end, we just return all of them, add it with this node and return it. So if this give us 3, this give us 2. Okay, so what will be our total node? 3 plus 2 plus 1. Why 1? Because of this one node. Okay, so how much? 6. So see here, there are only 6 nodes present into the tree. So this is how we can recursively, using DFS, we can perform it. Okay, and it is the simple one. Returning value means whenever a node, we just see returning value. So it, the whole tree or the whole subtree, we can say, return this 2. This whole left subtree return this 3, and it goes to 3 plus 2 plus 1. This is how returning works. Simple. See, here we just return the sum. Like we just go. I just explain the solution. I'll not pseudocode it or nothing else. So we just go to this 2 and ask what is the sum. Go to this 4, ask what is the sum. It is null. It is null. And the null value will be 0. So it will return 0. It will return 0. So 0 plus 4 plus 0 will return 4. Similarly, from here we can get the 5. So here we can return 4 plus 5, 9 plus 2, 11. Then we go to 3 and then 6. This 6 will return 6 according to this null node formula. This 6 plus 3 will return the 9. So simply 11 plus 9, 20 plus 1, 21. I think it is okay. So 1, 2, 3, 4, 5, 6. So 6 into 7 by 2, it will be 3, it will be 21. This is the simple formula. So the sum of the whole tree is 21. So this is how we can actually apply sum. We have to use recursion, which will be much more better. You could see here. See, we just take everything and we just return the sums. We are just returning the sums. See here, here it is 2, here it is 4. 2 plus 4. 4 plus 2, 6 plus 3, 9. Here it's written 9 here. Then simply here it's written 1. Then it's written 8. Okay, so 1 plus 8, 9. It will return 9. So 9 plus 9, 18. 18 plus 5, 23. Oh, not this. 18 plus 5, 23. Okay, so the answer is 23. This is how we can return. So not wasting time in here, I will not explain everything. So this is the actual question. Maximum depth of a binary tree. Okay, so what is the question? I am explaining it here. 4, 5, 3, 6. Okay, so what is the maximum depth? So I think the question is simple. Given a root of the binary tree, return the maximum depth. The number of nodes along the longest path from the root to down to the farthest leaf. Okay, so from this root to the farthest leaf. Okay, so here it will become 3. Okay, so let me check one thing with the question, that how. Okay, they will take 3 here, no issues. 1, 2 and 4. How many length we have? We have 3 length. 1, 2 and this 5. What is the length? Length is 3. 1, 3, 6. What is the length? Length is 3. So our depth will become 3. So I need 3, 9, 20, 15, 7. This one. 3, 9, 20, 15, 7. So if you see from this 3 to this 9, what is the depth? Depth is simply 2. Sorry, depth is simply 2. This 3 to this 15. Okay, so what is the depth? Depth is from root till the leaf node. Okay, this is simply 3. And from this 3, 20 and this 7. How it is? It is simply 3. So this 3, 3 and 2. What is the maximum? This 3 or this 3, because both of them are 3. So our output or our depth will become 3. Okay. So how could we calculate it? We just see it here. So we can use depth first search here. Okay, so what depth first search do? See, what depth first search do here? Depth first search go to the depth of a node. Like if we traverse from this root till the node left, we easily got a depth and we have to return the depth. So we are using depth first search here. So take this example simply. I am taking this example. So what does it does? So it goes this node, this root node, asks its left node what is the depth of this node from this 2 to the last node, and asks this 3 what is the left from this left to the depth node, what will be their values. So it will go to the 4 and ask what will be their depth. What is the depth of the 4? It is simply 1. Okay, so because it has null, so this null returns 0. Okay, it again goes to this null. It will again return 0. For this 0 plus 0 plus this 1, it will be 1. From this 5 also we get 1. So we return 1. So 1 depth is 1. From the left side it is 1. From the right side it is 1. For the 2 we will add. We will take the maximum of this both of them and add 1. It will become 2. Similarly from here this 6 will return the 1. This 3 will return simply 2. And what is the maximum between 2? It is simply any of thing we take. So 2 plus 1 will become 3. So I think I should take this example and I just do a dry run and then I will write the pseudocode for this. So 3, it will become 9, 20, 15, 7. Okay. So first recursively we have to traverse the tree, and this 3 asks this 9 what is the depth of this 9. So this 9 has only null nodes. Okay, and null nodes can return the depth of 0 because there is no node. So they will return 0. What is the maximum of both of them? Any of them. So 0 plus this 9, 1. So it will become 1. The depth of the 9 will become 1. And from this 1 to this 3, it will return 1. That depth of this left part is 1. Okay. Now it go to this 20. Then again go to this 15 because we recursively traverse every node until we reach the null node. So this we reach the null here also. So it will return 0. This null will return 0. 0 plus 0 plus 1. This 15 has the depth of 1. Okay, so it will return the 1 here with 20. Similarly for this 7, the depth will become 1. Okay, and this 1 and 1, what is the maximum? Any of them you could take. We need the maximum depth, so it will return 2. And from this 1 and from this 2, what is the maximum? This 2 is the maximum, so it will take this 2 and add 1. Why add 1? Because 3 has to do. So 1 plus 2 will become 3. So this is how we calculate depth. We go until we reach the null, and from the null we are traversing back and building our tree. Okay, so this one, I think, yeah. So let's write down the code. So suppose we are given a depth function, and the depth has the root of the tree, root of the binary. So if the root will become null, it simply means that we reach the null node or the int node. We simply return 0. And we first go to the left part, like until we reach the null, or until we reach the null or the leaf node, or until we reach the null, actually we have to traverse it. Okay, and get the value. So depth of root left. Similarly, we have to go to the right part also. So our right part would be depth of root right, and we have to return 1 plus maximum of left and right. Why maximum? Because we have to calculate the maximum depth. So from the right path or the left part, from where we get the maximum, we take it, we return it. Simple. Just evaluate it. Yeah, we did it. So if you see the visualization even here, so it goes to 3, then goes to 9, and then this 9 return 1. Why return 1? If you clearly see here, see the left child for this depth of 9, the left child is null and empty subtree has depth 0. The base case we reach, return 0 immediately, nothing to recurse into. The right child is also null for this 9. For this 9, the right child is also null. So we have to return 0. The depth will be 0. So the left and right both will be 0. So depth of 9 will become 1 plus max of 0, 0 and 1. Return 1 to the upper call of the frame. Okay. So we just return 1 here. And then we go to the right part. In the right part, we push it, and then we again go to the left part because we are traversing left and right for the 15. And again for the 15, the left child is null and the left subtree will depth will become 0. The base case return. And for the right, it will also become null. So it will also return, the left will be 0, the right will be 0, and the depth will be 1 plus max of 0, 0, and it will return 1. For the 7, the same thing. The left child is 0, the right child is 0, it will again return 1. And now the left is 0, the right is 0, the depth will become 1 plus max of 1, 1, which is 2. Then for this 3, the left will become 1, the right will become 2, the depth will become 1 plus max of 1, comma 2, which will become 3. So max of 1 and 2 is 2, and 1 plus 2 is simply 3. Okay. So our final result will become 3. And this will be our, you can say, pseudocode and code, because I will write this simply, this thing I will write in the code editor. So this is the question, integer. Okay, see, just watch it. If root is null, return 0. If root is null, return 0. So if root is equal to null, simply return 0. Okay, then what we do, we go to the left part and right part. Simply go to the left part, and we have to store it into a variable of integer. See, go to the left part of the max depth of root left, and simply go to the right part of the max depth of root right, and then simply return. See, I just go to the left part and the right part, and then return 1 plus max of left right. Return 1 plus max of left comma right. So recursively we solve it. So if we run it, it is working. It will be working. No issues. Okay. So it perfectly works. It perfectly accepts the solution. So this is our solution. Okay. So as you see here, see the time complexity will be big O of n. The time complexity will become big O of n. N is the number of node, and the space complexity will become big O of h. H is the height of the binary. Why h? Because at a certain point at max, the stack store the stacks can store the size of the or the height of the binary, not the size, the height of the binary. So this is actually n, not h. Okay, this is n and this is h. This is h. This is the recursion stack space complexity. Okay, so this is the solution of this amazing question and very easy question on depth first search. Okay, so go check out this platform, and while checkouting, use use this link please in the description to get a 7-day free trial. This is the platform dsa.chaicode.com. Go use it. Thank you very much.